Everything is fine. Okay, finally, I'm happy that we get this under control. Now, I would like to continue with the second chapter, and this is again a kind of introduction to the bigger chapter, which is the modeling of trace experiments. So we started with a case study, which was a kind of transition between yesterday tracer properties and today modeling. We already mentioned the software StanMod, and after the break I will have a longer lecture, a bigger lecture about the advection dispersion equation and how we use this for tracer experiments and planning tracer experiments. And I would like to start now with tracer mass estimation methods. Now, this is the outline of a tracer test. So this is how we actually plan a tracer test. These are the different steps of a tracer test. Now, we have a problem and an objective of the tracer study. For example, we want to know the source of a pollution. We want to know the velocity of tracer transport, of water transport. We want to know, are there preferential flow paths? Now, we then have to do a reconnaissance study or a preliminary study of the hydrological system investigated. So you should go to the site and have a look at the site and take time to actually understand the geology, the soils, talk to people, get an understanding, a conceptual idea of what is going on there. How thick is the aquifer? What is the aquifer material? What do we know? What has been done before? Have there been trace experiments before? Have there been environmental isotope or tracer studies? So actually understand the system as much as you can. And it's always a very good idea to simply talk to people. Talk to a farmer, ask someone. He will maybe share information that can be extremely valuable about observations that help you a lot. Then you should choose the tracer, and I have tried to instruct you and to inform you how to choose tracers yesterday. So groundwater tracer, surface water tracer. Of course, it also depends a little bit on the infrastructure, on the devices that you have got. In the videos that I have put on the YouTube platform this morning, you see 3 different devices and how they can be used. So please have a look at these videos. And of course, you need to be able to measure the traces. So this also determines your tracer selection somehow. Now then you start to plan and prepare your trace experiment. And as I said, I would most often try to combine natural traces and artificial traces. Look at the chemistry before. Take some samples for stable isotope analysis. Maybe even consider age dating. If you find there's no tritium in the water, you see there's no point in doing an artificial tracer test. Collect hydrological data and evaluate it. Maybe you can learn something about this. The timing of the trace experiment is extremely important. If you want to study interactions between groundwaters and rivers, you need to actually have an idea of when the groundwater feeds the river and when the river feeds the groundwater. Now, it makes a huge difference whether you do an experiment in July or in December. So we always try to choose a time when the system is active, when there is connectivity. So it is very difficult to do a tracer test at the end of the dry season, at the end of the summer. It is much easier to do a tracer test in spring when the whole system is wet and activated. However, you have a certain question, so it might be interesting to understand or learn something about the tracer system at the end of the summer. So it depends on your question, of course. Now you need to prepare your sampling. So you need to know when you sample exactly. This is crucial. If you sample too early or too late, you don't get good results. I think it has happened to almost everyone who's doing tracer tests regularly that he was wrong about something. And my experience is you are often wrong in that manner that tracer comes earlier than you think. So there's always a possibility of preferential flow, so you should be prepared to sample early. However, it also happens that the tracer never comes, it simply gets stuck, mainly if you work in the unsaturated zone. So what we do today and what I will present in the lecture later on is actually about getting the right timing by understanding the tracer breakthrough curve. And then you should already anticipate the laboratory analysis. A second reason for modeling of tracer experiments is that you want to anticipate and understand the right concentration of your tracer at the monitoring point. So you want to calculate the mass. This is what we do now. So there are some simple methods that I will introduce now, and there are complicated, more elaborate methods that we will do afterwards. I suggest that, like yesterday, we continue at 1 o'clock. So I have an appointment now at 11 o'clock. I will be out. I've prepared some videos for you at that time. So 1 o'clock I'm back, and we'll have 2 hours of lecture on the advection dispersion equation. We'll choose to do this through a YouTube live stream again. Then it's recorded and you can actually rehearse. So at 1 o'clock we have then the big lecture about advection dispersion equation. Okay, so how do we actually calculate the tracer amount? Before we do that, some errors, things that you shouldn't do. This is an example of not enough. So you didn't sample at the right frequency. So you see that sampling at high time intervals, like 360 minutes in this case, lets you miss the peak completely. So you are not even aware that there is a peak, or worse, you even think there is a peak at 6 hours, which is wrong. Now, if you increase the time interval, you get a peak at 2 hours, which is more or less right, but it looks ugly. So if you present this in a report, people know, you just had 3 samples for the breakthrough curve, and this is not good enough. Now, you should have the right interval, which is 10 minutes or more. On the other hand, you need to somehow handle your resources. So my experience is a tracer experiment requires 200 samples, not much less, not much more. So if you get into 1,000 samples, you are lost. That's it. I mean, you can't handle it. So you should be able to do your tracer experiment with 200 sample bottles, not more. So you see that understanding the breakthrough, anticipating correctly when the tracer will come is very important. And you learn after 1 o'clock how to do that. So you need to consider the characteristics of the site. You need to understand the injection technique and site. You need to have all the material ready. So you must prepare a list of material. You often work with other people. You need to organize well what everybody does. And the key thing is that you understand the breakthrough curve when it comes and what the concentration will be. And based on that, you define your sampling concept and later on your analysis and interpretation. It's always good to have a risk analysis and contingency plans. What happens if I don't get a tracer? What happens if my tracer concentration is too high? You should anticipate this and prepare for these 2 cases. Now, how do I calculate a tracer test? And there are many equations. You see dozens of them, but they all have one thing in common, and they are all very simple if it comes down to the tracer concentration. And I have actually already introduced the principle yesterday. You simply try to estimate the volume of water that is traced. So as I have elaborated yesterday, you have your aquifer, you have your injection borehole, and you have your sampling borehole. And you simply try to, this is the flow direction, you simply try to estimate the volume of water that will be traced. So obviously, the distance is important. Obviously, the depth of the aquifer or the thickness of the aquifer is important. And now the rest is, and the key question, how much does it spread? So how much does the tracer cloud spread? So this is actually then the volume of tracer that, so I try to draw this in 3 dimensions. So this is actually the volume, and you try to estimate this volume. And if you have this volume, you assume that the volume is has fully mixed, so that it has the same concentration everywhere, which is wrong, but it gives you a slight overestimation that accounts for some losses that you have. So you actually try to estimate the shape and volume of this triangle of tracer. And this is a simple equation, as I showed yesterday. It's basically the length times the width here. This is a triangle, and multiplied by h. So this gives you the volume. Now this volume needs to be multiplied with a porosity. So length times width. And once you have the volume of the aquifer, you multiply with the porosity, which gives you the volume of water. And once you have the volume of water, you define your target concentration that you want to measure. And the target concentration is the volume of water divided by so this is the mass injected divided by the volume of water, and this gives you the target concentration. So this is basically the very simple process that we will use. I will elaborate on that, and we will actually do this for several examples, and I will show you much better methods to estimate the tracer concentration. However, you always should check yourself with a very simple method, which is calculate the volume of water that is traced, and define the target concentration, and calculate the mass by multiplying the target concentration with the volume of water. You can simply rearrange this, and then you get the mass equals target concentration times volume of water. Now, why is this so important? When you do a trace experiment, you will get nervous before. There will be people involved, maybe there's press, it's in Munich, people will actually see when you make a mistake, and in that case, you should have methods that you trust. And you trust such a simple calculation more than a complex advection dispersion model where you have doubts about parameters. So I always use this very, very simple method, simply based on volume concentrations, volume calculations, and double check it. You should always use the 4I principle and share this with colleagues to be sure. With time, you get more experience and you feel comfortable. You know more or less by heart which concentrations you need for specific cases and applications. Okay. You can have a look at these different equations. We'll go into more depth. We'll then review the mass estimation equations, go through some of them, and at 1 o'clock I will start with the full lecture on advection dispersion modeling. Please have a look at the different videos that I've prepared on YouTube, and see you later at 1 o'clock. Thank you.